Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we're going to begin building out our self-driving car project. So I have launched my Unreal 5 engine, and now I can choose from a series of templates. Let's choose from the bottom here, Vehicle Advanced. This is going to be the template that we'll use because it has a set up vehicle already that you can move around using either the WASD keys or the arrow keys. And it also has a racetrack and a landscape racetrack as well. So that's the one that we're going to use. Now under project defaults here, choose C++ instead of Blueprint because we will be writing C++ code later. Then you can include starter content if you want to. It's not required. Choose a project location and then give your project a name, for example, self-driving car. Then press create, and that is going to launch for you the Unreal editor. And here our project has been created. My editor may look a little different just because I've zoomed in my text size and my icon size. Here, let's press play. It'll be in the top center here. For me, it's on the side just because I've zoomed in. And you can press play and click inside of the viewport, and then you can use your WASD keys or your arrow key to move around. Sometimes the vehicle fails to move, so just press escape and press play again. Okay, and then you should be able to move the second time around. You'll also notice there's some engine sound that's simulated, but we can turn this off. Let's just hit escape, and let's open up our C++ file inside of Visual Studio. Okay, here I am in Visual Studio. I'm going to open up my self-driving car pawn C++ file. So that's just inside of your project, and then you'll have your project name. And your project name will be in front of every file here. So just look for your project name followed by pawn.cpp, which is the file extension for C++. Okay, here, let's just look for anything that has to do with sound, and let's remove it. So I'm going to just Control F for sound, and just comment it out by hitting Control K. Let's see, just commenting it out with Control K and then followed by C. So let's use that keyboard shortcut. You can also just put in 2 forward slashes as well if you want to do that manually. And let's just look for any more instances of sound. Okay, here we have the setup for the audio component. Let's comment all that out as well. Again, just by highlighting what we want to comment out, and then using the keyboard shortcut, which is just holding Control K and then pressing C. As well here, we have an engine sound component. I'm going to comment that out as well. That means it'll be hidden from the compiler, and it's just there for my reference now, but it won't actually be executed by the compiler. Okay, now we have made some changes to our Visual Studio project. So before these changes will actually be reflected in our Unreal project, we have to compile this code. We can't just simply build it because then we won't have the changes be compiled. So instead you have to press debug here, or F5. You can also go to the debug window here and just select start debugging. The fastest way is just to use this local Windows debugger. The reason being that by using the local Windows debugger, you actually are compiling the code. Okay, so here you go. Let's just allow it to do its job. It can take a minute sometimes to compile. Here we go. If you go to the output window, you can see the progress of the compilation. We've built 4 actions with 12 processes. Okay. Now, once the compilation completes, an instance of Unreal is going to be launched. All right, and this is going to be your same game, but with these compiled changes. And note that you will be running in debug mode, which means that your Visual Studio solution will be running at the same time that your Unreal project is running. So you have to just remember that any changes you make while you're in debug mode, such as I am right now, You can see my diagnostic tools have popped up, and I have my pause, stop, and restart buttons as well. And this means I'm in debug mode. So any changes I make, whether in the code or in Unreal during debug mode, those are temporary. So if I wanted to make a change right now, I would have to stop the debugger and then open my Unreal project via my File Explorer or via the Epic Games Launcher and make the changes again. Because any changes in debug mode are temporary, so just keep that in mind. Now I can press play and I can click in my viewport. Sometimes it doesn't run the first time, so just press play again and click in the viewport again. And now if I move using my WASD keys or my arrow keys, I no longer hear that engine sound. So we were able to successfully edit our C++ code to turn off this sound. Okay, here I am falling off the loop. I can hit escape and play again at any time, and then click in the viewport and start moving around with my keys. Sometimes if the car doesn't move, it just means it doesn't know where it should go. It gets confused, so this can be something just to watch out for. Just hit escape and restart, and then you should be able to move. All right, let's check out our racetrack a little bit. We have actually two racetracks. First, this artificial racetrack, and then one in a landscape, so for more of a natural environment. And you can build your own as well, but this template gives you a great starting point for being able to move around this vehicle, whether you're doing that manually with a player input or with a neural network or even just math or a controller. You have this great setup. This template is used for not only games, but also for training self-driving cars in different environments, because you could spawn pedestrians and other cars and different things to happen on this racetrack. Okay, so not only do we have this artificial one, but we also have a natural racetrack here in the middle of this landscape. So you can test out your car on different terrains. Okay, here I am moving around, and you can see physics is all enabled. I can bounce. The car behaves just like it would in the real world. You can also see everything that you have just by escaping the play mode, and then in the top left-hand corner of the viewport, change your mode from perspective to top, and then scroll down to zoom out. Currently we're in wireframe mode, but if you go to the top left-hand corner of the viewport and change from wireframe to lit, you'll actually see all of your contents. So here we have our landscape track, and we also have two tracks that are artificial. This straight track with a loop and a curved track also with a loop and with obstacles. Coming up next, we're going to build our own track, because in order to teach our vehicle how to do simple cruise control, we need to have a straight track without any obstacles, without any loops or curves, to keep things simple. Later, you can train your car to turn, to do loops, to avoid obstacles, and more. But we have to start off with just a simple straight track. As well, not only will it be straight, but it also is going to have some hills. That way it'll be harder for our vehicle to maintain the same speed. So we're going to implement some hills, some inclines in the track as well. So join me in our next lecture. We're going to get started. Hello everyone, and welcome back to our course. In this lecture, we're going to build out the blueprint for our track, our racetrack, or our road. Because in order to train our self-driving car to perform cruise control, we need to have a straight track that just goes in a straight line to keep things simple, so there's no turning that the car has to do. And also we'll have hills or different inclines going up and down throughout the track, so that way it's harder to maintain that constant speed. And in order to build out this track, we need to build a blueprint for each portion of the track. And this is what's called a track spline. A spline is a line with two ends called points, and more points can be added to the spline between the beginning and end points to change the backbone of the spline. So a spline can be thought of as a backbone, and you can change each bone in the backbone in order to change the inclination of our track. So let's get started. Open up your Unreal project via the File Explorer or via the Epic Games Launcher. Make sure you're not in debug mode and you're not running Visual Studio right now, because we want to make permanent changes. If you wanted to test out your game, if there was some bug you had to debug, then you would use Visual Studio, or if you wanted to add code, you would use Visual Studio. But for building out some change in Unreal, we have to open the project in Unreal. Okay, next I'm going to just make sure I'm in perspective mode here and maximize that viewport. All right, let's get started building out our blueprint. So I'm going to go into our content drawer and go into our blueprints folder. And let's see, if we don't have a blueprints folder already inside of the project, then we can just make one. Now inside of starter content, we have blueprints, but we don't want to put our custom blueprint into starter content because that is going to keep your files a little messy. You want to stay organized. So let's go into our project vehicle advanced folder. Here, I'll just make our own folder for our blueprints. So I'm going to select add here, and let's see, not a blueprint just yet, but a folder. So I'm going to add here a new folder and call this blueprints. Then double click inside of that, and now we're going to add a new blueprint class. And the type of blueprint we're creating is going to be an actor, which means just a static object. We don't need our road to move around or to get input from the user, so it can just be an actor. An actor is just a basic object. So I'm going to select that, and then let's call our blueprint BP underscore track spline. Okay, there we go. Now let's double click on this blueprint, and it's going to pop it open. You can drag it beside your map in the layout. Okay, here we can see in our viewport, currently we don't have any content for our object, but we're going to give this a spline and then use blueprints to set the points of that spline. Okay, so let's go into our object. So we're going to go to components. This shows all of the components of the blueprint. Currently we just have the self and the default root object, which really means we have nothing. So I'm going to press add here, and I'm going to search for a spline. Okay, it's under utility. This is a spline shape which can be used for other purposes and contains debug rendering capabilities. Okay, let's add that spline and hit enter. You'll notice we're also prompted to save and compile. Now if you look in the game, you'll just see this point, okay, this point in the object. Let me click F to zoom in on it, but really it's just a point. Let's go ahead and actually give this a road visual, as well as allowing it to have points that can be manipulated, and we'll do that via our blueprint. So let's start inside of our construction script function. Okay, here we're going to write the functionality for what we want this blueprint to be able to do. What we want to do is to go through all of the spline points in the track. So any point where the track might want to change its incline, that is a spline point. And at that point, we want to be able to create a new spline mesh, which just means a new part of the track. And we want also that to be able to be adjusted if you wanted to change the width of the track to make it wider, or change the height to make it taller. We want it to be adjustable. So first, let's loop through all of the spline points and create a mesh at each point. And we, the developer, will be able to manipulate how many spline points we want. If we want to add a new point of incline, we'll be able to do that. Okay, so let's go ahead and drag off a new node from the construction script function, which is just going to allow us to construct or build our blueprint visual. Here I'm going to search for a for loop, which is under flow control. So this means we can execute some action on a loop. We're going to start at index 0, and our last index is going to be our number of spline points subtracted by the first and the last, so just -2. This is because we want to draw a piece of the track at every spline point. So first we have to get how many spline points we have. So I'm going to drag our spline object here. You can see we have the spline. If you go under your blueprint, you also have this spline component as a variable. So you can just drag that spline variable and use the getter because we're getting its value. So now we have our spline on our event graph here. Next, I'm going to put this to use. I'm going to get the number of spline points we have. So let's right click here and get our number of spline points. Okay, so select that first option there. And okay, we already have our spline as our target. That's fine. All right, so we're getting how many spline points make up this spline, because remember, this is our track spline, which has a spline object as one of its components. Next, we also want to subtract 2 because we don't want to draw any at the beginning and end. So I'm just going to here get the value of the number of spline points, but then also subtract, and I'm going to subtract here 2. And we can actually make this into a variable as well. So let's go ahead and extract this, promote to a variable. Okay, and I'm going to call this my beginning and end. Beginning and end spline points. Okay, so that will be 2 of them. So make sure that your value for that is 2, not 0. Okay, so we're subtracting the beginning and end spline points, and the result of that is going to be the number of meshes we have to draw. Because for every spline point, we have to draw a new mesh, and that mesh is just a piece of the track. All right, next up, how do we actually draw the mesh? For that, we're going to use the function add a spline mesh component, and we're doing that at every single spline point. So we can use the loop body of our for loop, and we're going to call add spline mesh component. Here we go. That is going to happen for every spline point we have. The target is going to be self, manual attachment, and relative transform can be left as is, but for this spline mesh component function, we do have to put in the actual mesh. So if you go into your details window, make sure you have your function selected, the add spline mesh component. Here, if you click on that function, you actually have to set its mesh. Okay, so let's choose a static mesh for it here under the details window. The static mesh here, we are going to search for our straight, full, half, or quarter. Okay, so you can select how long of your track you want. We can just do half. This is a piece of the track. You can already see it right there. Okay, and let's just go ahead and save all this. All right, now we can compile this, and if you go into your viewport, you'll actually now see you'll have this track. This is just a piece of the track. And the reason we have this is because we already had a spline point. So we already drew one of the pieces of the track. Okay, and what if we wanted to have more pieces? Well, we would just add more spline points. And every time you add a point, you can also change the incline at that point. Okay, here currently if we select this, let's go ahead, choose the translation tool. You can also choose the resizing tool. So we just have to go to our component and make sure you select your spline here. You can see the point, okay, and you can move that around. So let's say I move this over. Well, you'll see it actually won't be followed, so we have to add some code to make sure we can have it follow our spline. Let's say we also wanted to select or resize our spline. Okay, currently you'll see as I change a spline size, my track doesn't actually follow. So let's add some more content into our blueprint to allow our road to be resizable, because we might want to have each of our spline lengths to be longer than just this short amount. Okay, so let's go ahead and do that in our function. In our construction script here, we can set the forward axis of our spline mesh component and set where it begins and ends. And we can set that to be determined by the spline point. So if I move or if I resize the spline point or change its incline, we want the mesh to actually reflect that, because by default it won't. So I'm going to drag off a node here and select set forward axis. All right, and then our target is the self. In forward axis will be X, and we do want the mesh to be updated. That will allow it to be dynamically updated. The target here, we can pass in the return value of the spline mesh component, because the target is not just the spline itself. The target is the actual mesh. So we're setting the forward axis of the mesh. Let's also set the starting and the ending point of the mesh. So we can continue on after we've set the forward axis. Here we're going to then set start and end. Okay, and here we have several arguments to pass in. First, the target is again the mesh, so drag over that mesh. Next, we have starting position, starting tangent, ending position, and ending tangent. So this allows us to set the location and also the incline using tangent. So for that, we have to get the location and the tangent at our spline point. Right, so how do we actually get that of the spline point? Okay, well first we can use the spline point index, because remember we have this for loop, and at each index that represents each spline point. So we can use this index as our way of finding which spline point we're at, and that spline point is going to be the position and the tangent that we should use. The starting position and the starting tangent should be the current spline point, and then the ending position and the ending tangent should be the next spline point, because we're setting the mesh. And when you have a mesh, when you have this track, it's not just one spline point. It has a beginning spline point and an ending spline point, on both sides. All right, so it goes here. This is the starting one, and then that would be the ending one on the other side. Because these red bars, those represent the start and the end of the track. So if we wanted to perhaps resize by the width or the incline of this little piece of track, we'd have to use two spline points, the starting spline point and the ending spline point. So that's why we have in our construction script, you have starting position, starting tangent, ending position, and ending tangent. All right, so let's use our spline points. For each spline point, we need the current spline point for the starting position and the starting tangent, and we need the next spline point, using the next spline point to set the ending position and the ending tangent of our current piece of the track. And we'll have a piece of the track for every spline point. So between every spline point, there will be a piece of the track. And each piece of that track is somewhat independent because you can change its incline. All right, so we're going to here, let's grab a new function by right-clicking and selecting here, get location and tangent at spline point. We can use this because we have a spline component. Okay, our target is our spline. Then we have a point index. This refers to the spline. So we're going to use the index from the for loop as the point index of our spline point. The coordinate space can be local. This returns a location and a tangent, which is exactly what we need for our mesh. We need a starting position, a starting tangent, an ending position, and an ending tangent. So this current point index, that represents the starting location and the starting tangent. So we just drag those from starting location to starting position and from tangent to start tangent. Now you may be wondering, what about the ending position and the ending tangent? Well, that is just going to be the next spline point, because remember, our track here is just a series of points with a mesh drawn in between. So we need the starting point, but then we need the next point, so we know where our piece of track ends. So how do we get the next point? Well, all we have to do is take the index of the current point and add 1. So let's do that, because adding 1 gives you the next consecutive point. So I'm going to drag this index, and this time I'm going to add 1. So let's use the operator to add, and here we'll add 1. And I'm just going to promote this to a variable just so that I don't leave any magic numbers. So I leave it clear what every variable, what every number means. Because if I leave this at just 1, it may be confusing. All right, so I'm going to call this variable my next point index. All right, and I'm going to set this to 1. All right. And really, it's not the next point index, it's the amount to add to get the next point index. So I call this to next point index. Because the next point index is just the current index plus 1. So that's why we have that. Now the result of this is going to be our point for the ending position and the ending tangent. So we actually need to call this function get location and tangent at spline point again, but this time we need to pass in a different point index. So I'm going to right click and call that function get location and tangent. There we go, at spline point. Again, my spline target is the same. My coordinate space is local, but my difference here is my point index. I'm going to pass in that next point index. This function will return a location and a tangent, which I can drag to the ending position and to the ending tangent. Awesome. Okay, there we have our blueprint now. I'm just going to zoom out a little bit here so you can see this and perhaps screenshot if you need to. All right, there we go. That is our blueprint. So now let's go back to our viewport, and here we have our track. And if we go to our viewport and select the spline, we can select one of its points here on either side. And let's say I move it up, then look at that, I can resize it. And if I change the incline, the mesh will also adjust to that incline or that rotation. So I can make this wider. I can also set an incline on it. If I go to this other side here, right, then let me rotate around. All right, here we go. We can see on this side, here we have the other border of the track. So here we have one border, and this is going to run along the left side or the right side of the track, just on one side. This will run the other side, and then our track is just going to be one really long instance like this. But we're going to have multiple pieces. So this is one piece, for example. This is one piece of the track. And then if you want to add another piece, you just add another spline point. And we're going to do that in the next lecture. You just add another spline point. For example, you right click and duplicate the spline point. And then if I just move over to the side here, I can drag over that second spline point, and look at that. I can then incline that spline point. And look what we have now. We have this line underneath representing the curve that the splines can make. We have our 3 spline points now, and this shows the point of the spline points. We were able to use the spline point to have different parts of the track. This flat part is piece 1, and then this inclined part is piece 2. Okay, and we can just put these together just by creating more spline points and then making, therefore, different parts of our track. So coming up in the next lecture, we are going to actually make the whole track just by duplicating the spline points and changing the incline, because we can't have a completely flat track. That will be too easy for our car. Let me just undo all of this. That was just for demonstration, because one piece of the track should just be simple. It should just be this simple flat object, and then we can manipulate it when we actually create the whole track back in our map. You could also have a blueprint for the whole track. This here is just one track piece. That's why it's called track spline. All right, so that does it for this lecture. Great job building out this blueprint, and I will see you in our next lecture where we'll put together the whole track. Hello everyone, and welcome back to our course. In the previous lecture, we built out a piece of the track via a blueprint, and in this lecture we're going to build out the whole track itself. So let's go back into our map here, and we can see we already have a landscape and some other tracks, and we can just delete these from our game or hide them, or just make our track right beside these other tracks. Typically you want the track to be right in front of your player, so let me just delete any other ones that are in front of it. So I'm going to select all these objects, and let's see, maybe move up with the E key here and take a look at what I have. Move forward with the W key. Okay, we have all these pieces of the track. You can see we have a bunch of obstacles too, and we can just delete these. If I click on one of these objects and then go into my world outliner, I can see that they're inside of track 2. So let me just delete all of these. You don't want to just delete the folder, because that will just delete the folder, not the object. So let's right click, edit, and delete all of those objects. You can also just hit the delete key. Okay, then we can delete that folder. Okay, so now that track is gone. We still have some obstacles in the way, so let's just select those obstacles. Go to the world outliner, select one of the obstacles, and see, here they are. They're called the bump wedges, so we can just delete all of those as well, because we want to start off simple for the game. for our track, and later we can put all those bumps back in if we want to include obstacle dodging or even bumps in our track to make it harder for our player to maintain the speed limit. Okay, if I press F, that will zoom me in on my player. All right, here we go. Next, let's put in our track in front of our player. So I'm going to go into my content drawer. Here, I'm going to drag my spline from my blueprints right in front of my player here. So I'll just drag that and drop it. Okay, now we can see that we have that track right in front of our player, but currently this is just one piece. We need to add more pieces, and we can also make this piece longer. All we have to do here is select our spline point at one of the ends of this little piece. So select the spline point, note here, you have to have that point selected, and then if you drag that out, you're making this piece of the track longer. Okay, so you can make that as long as you want. Then this is not your whole track, this is just a piece, because we want to have inclines inside of our track. So I'm going to zoom in here, right click on that ending spline point, and then I'm going to duplicate it. Alright, so then if I now drag out the point, you'll notice a previous spline point actually remains. And if I lift up the second spline point here, or the last spline point, you'll notice only this portion of the track lifts up, because these two are now separate meshes. They're still part of a greater whole, but they're separate. Okay, so now I can again drag out that spline point, and so you can rotate around here. Let me move with my WASD keys and my Q and E keys, and check this out. Here we go. We can now see we have that flat part, then we have this incline. Okay, next let's go ahead and add in another point, another spline point, and we can make it flat again or have a decline, because we want to make sure that our self-driving car has some challenge. It doesn't just have a flat road. So I'm going to right click on the spline point again and duplicate it. Then if I drag out the arrow, look at that, we can see we have another separate piece of our track. Okay, so let's just move over, and you can make that flat or we can make it a decline. Let's just keep it flat for now. And basically you can have as many of these as you want, as many spline points. All right, so let's right click and duplicate the spline point again, drag it out, and now we can lower that. We want some declines as well. And look at that. Now we have declines, inclines, and a flat piece. Now you want to make this relatively large. So let's go ahead and grab our spline point, maybe make it a bit longer here, and then lower it down again. All right, there we go. Feel free to make it as long as you want. It doesn't have to be short. One of these tracks could be quite long. Then let's go to the end here again. Let's see, I'm going to use my WASD keys to move around with my left mouse button pressed. Okay, you can see there's some decline there. Maybe we want to have some flat track again. And don't worry if it goes off of the floor here, because our car is only going to move in a straight line for now. So it's never going to fall off that track. I'm going to right click on the spline point and duplicate it, and then drag that out, and look at that, we have another piece of our track. Okay, let's move around. We can keep that flat because we want some flat points as well as some inclines and some declines. So after this flat point, let's have another incline. So I'll right click, duplicate the spline point. Right, then I'm going to drag that out again and make it higher. There we go. And make it a bit longer as well. So we want to have these varying inclines and flat parts so that our self-driving car has to maintain the speed limit. And it's not just a matter of keeping the same speed, they actually have to pay attention to the environment, because as a car goes up a hill, it's going to naturally go slower, so you need more throttle or more gas to keep the same speed. If a car goes down a hill though, it's naturally going to go faster thanks to gravity, so you need to have less throttle or less gas in order to maintain the same speed. And that will be the task of the self-driving car, to maintain the proper amount of throttle with respect to the actual speed of the car. because the car does respect gravity. It's going to go faster on a decline. It's going to go slower on an incline. It's going to stay relatively the same on a flat surface, but there could be friction involved. Okay, so here we go. Let's just keep going. Let's make this longer and just keep adding parts to the track. So here I'm going to grab this, right click, and add another point by duplicating the spline point and moving it out. Let's see, it's hard to tell what is going on here, if it's high, if it's an incline, if it's a decline. It looks relatively flat. We can also enter a different mode. Okay, so you could use this icon at the top right hand corner to show different modes, and you can also just maximize one of the modes and then just change in the top left hand corner. For example, you could enter orthographic right view, and this is actually going to show you your track here, and you can change it from lit to wireframe, so you only see the wireframes here. Then you can select your track spline from your world outliner, so you see where it is, and you can see that is the car here, so that's the starting point. Then we have our track going. Okay, there's quite an incline there. Then we have a flat, then we have a decline. Okay, then we have flat again. Okay, this is actually getting quite long, which is good. Then we have an incline, then we have some more flat. Okay, we want to have some variety here. So again, just like in regular perspective mode, you can double click on a spline point to select it and then move those arrows down. Okay, and then you can go back to perspective mode just by going to the top left hand corner and changing that to perspective. Okay, now you can also just test out the game by pressing play. And I say game, but I mean the simulation. You can test out to see how long the track is, because you want it to be relatively long for your test. You don't want it too short, but you don't have to spend all your time having it too long anyway. You'll also notice here the car actually dips right underneath the track. It doesn't even go on the track, and then it hits the boundary here. So we have to enable collisions on our track. If you want your car to actually be able to go on the track, you have to make sure that the track blocks collisions and doesn't allow them to go through. So open up your blueprint for the track spline, and then here select your function add spline mesh component. This is what actually draws the visual of each track piece. So this function is going to have a collision category here, and we want to change collision presets from no collision to block all. Then I'm going to compile and save that blueprint, and now if I press play, my car is going to respect the track. That's because now, instead of allowing all the collisions to go through the object, meaning that we had our track here just let everything go through it because the collision was no collision, that meant that we had our track just ignoring every collision. So anytime an object touched it, it just ignored that collision. Okay, but now our track actually obeys collision. And you also notice we hit the boundary of our game. So we actually hit the bounds because on some sides of the game, there actually is a boundary, so you can't go through it. So let's go into our world outliner and just go onto our player by pressing F. Let's see, double clicking on that. Now I want to find the boundaries as well. So let me just search through our world outliner here, and we want to find the blocking volumes. There they are. So these blocking volumes, if you double click on them, you can see where they are. Okay, I want to just delete these blocking volumes from my game. So I'll right click on the actual objects. Okay, and then I'm going to go to edit and delete those. Okay, now I'm going to press play again. And this time our car is not going to bump into the edges of the game. That was just so that a car would not fall off of the actual world, but in our case we want the track to go further than the bounds, so that's why we had to delete those, but you can easily put them back in as well. Okay, so if you think your racetrack is long enough, then you can leave it as is. I'm going to make mine a little longer because, as we saw, it fell off after not a long of a time. So let's go into our right mode here, our right wireframe. Here we have our car, and then we have our spline, our track. So let's go ahead and make it even longer. I'm going to scroll down to zoom out and then right click and hold and move my mouse to go to the end here of my track. Then we can just right click and duplicate a spline point and add a new piece to the track. And we can just keep doing that as long as you want. So going to grab that spline point at the end, right click and duplicate it, then drag it out. Okay, let's see, drag that out and make it on a taller incline as well. Let's drag it out even further. Want to have a varying landscape here. I'm going to right click, duplicate it again, and drag out that spline point. Let's have another flat area. Then right click, duplicate. Let's have another decline. Okay, you can make them long or you can make them short. Whatever you like, we're going to use to train our initial car here. Okay, that is long enough. There we go. We can also just make the last one super long as well, just to make sure the car never falls off. But if you have these areas that are super long, then it gets easier for your car to maintain the speed. All right, there we go. This will be good enough for now. You can make this longer at any point. So coming up next, now that we have built out our landscape and our track specifically, we can start working on building out the functionality for our car to learn how to perform cruise control on this track. And then that can be adapted to any track as long as it doesn't have to turn, because turning is another functionality. So join me in our next section. We'll start building out the functionality for the cruise control.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.